Okay, the topic is payment with RhoMobile Suites. Payment industry is going through a lot of changes recently. Very interesting, a lot of breakthroughs, new technologies coming in. So this is the right time to be in payment solutions. The agenda today is like three of them. One is just understanding the basics of payment. Payment is a pretty complicated process because money is involved. So understanding the basics of payment, and then what is Motorola offering? It's MPM 100, Motorola's payment device that was released just a few days ago, how it works and what you can do with that. And after that, we'll talk about developing payment applications using RhoMobile. And then we will say, what's our future looks like? What's the vision? What do we want to go from here? That's the agenda. And I do have a demo. We have written a RhoMobile application to take the credit card information, and then it pretends like it's doing bank transaction. You can scan, and then you take the credit card information, and then you can print a receipt. That's what the demo does. And we took the demo application, ran it on ET1 Android device, worked fine. Took the same demo application, ran it on Windows mobile device, worked fantastic. So that's a good demo, or at least to begin with. Okay, so the basics of payment. What is a payment today? Well, let me start with this. The payment is a lot today in terms of you go to the grocery stores, you go online. They all have different types of payments in terms of what happens behind the scene. But we are getting into the mobile payment here with our devices, which are mobile devices, Motorola devices. Right? So in a nutshell, what happens when you go to the grocery store? Someone scans the items, does a price check, and then comes up with the total and taxes, figures out the taxes, and then they will show it to you, and then you have to say, yes, I want to pay for that. And then you take your credit cards, swipe it here in US, tap it in UK or in Europe. And then after that, bank, you may have to do PIN, you may have to enter PIN if it's a debit card transaction. And signature comes later, but I just added it there. And then it goes to the bank. A whole different world up there. A lot of things happen there. And then the approval comes through. And then you take that, and then you print the receipt, hand it to the customer. That's the end of the transaction. That's the basic. But there are a lot of things that happen in each of these steps. We won't get too detailed into this, but I'll skim through all of those steps. And if you have any questions, stop me and ask me. And if I think that it's going to take a whole big discussion on it, we can do it offline later. How many of you are already in payment today? Oh, okay. So maybe you can correct me if I'm making mistakes. Because we are also very new to this. We weren't in payment before. We had DCRs before, and DCRs was kind of a debit card reader. We did a few things, but for the first time we are getting into the real payment. So this is what happens. So this is the latest device that I was talking about, MPM 100. We also call it MPM, Mobile Payment Module. At least in this discussion, I may say reader, terminal, payment device, any one of these names. And then we have Motorola device, mobile computer. That's for our devices, right? And then you have, so the conversation between mobile device and MPM happens with Bluetooth. And then Motorola device talks to the gateways, acquirers, card networks, all of those through Wi-Fi or WAN, depending on your setup. So that's the picture, overview picture of what will happen when you start using Motorola solution. Right? Okay, coming to that, today in US, a lot of us have credit cards, and they're all MagStripes. Maybe a few of us have smart cards, but many of us have only MagStripe. MagStripe is good for, it does payment. MagStripe readers could do also other things, driver's license and for other applications. Normally, there are about 3 tracks. There may be 4 tracks in some countries, but here in US, it's 3 tracks. It will have a number of information like account number, account holder name, expiration data, and all of that. There are MagStripes for credit and MagStripes for debit. But the problem with this is it's not very secure. Fraud can easily happen. And also, it stores limited amount of data compared to the smart cards. The thing with this, even if fraud occurs, you won't feel the pain as long as you're using a credit card because you don't have to pay for it. All you have to do is claim and say, I didn't do that. And they will take it out of your account. They will cancel it. Well, that's a whole different thing if you're using a debit card, right? So you're already paid for that. So, but someone else is paying for the fraud, and the goal is to reduce that. One of the ways is to go with smart card. So that's MagStripe. That's low tech. That's there today, all over the world. Now we are coming to the next generation of payments, right? EMV, EuroPay, MasterCard, Visa, but now it's Amex, Discover. All of them are supporting this all over the world. So it can do credit and debit just like MagStripe with chip card technology. There is a microprocessor in there. And it's also card IC card, smart card, chip and pin, number of ways. It has more security and capabilities built into that. We'll talk a little bit about all of these securities and capabilities in the next few slides. And it may sound new to us, but there are already 1 billion EMV cards out there in the world. So advantages of EMV. For most of the part, we're going to talk about EMV here because MagStripe is pretty simple in what it can do and how the process works. So with EMV, it's harder to do data skimming. So today, you go to the restaurant, you give your credit card to them, and they take the credit card, and they go away somewhere, and then they bring back the check, and then you sign it. What happened there, you don't know. And the restrictions, if there are any restrictions, country restrictions or bank restrictions, if there are any, that's not easier to enforce with MagStripe. It's much easier with smart cards. Offline transactions, where you don't have online banking services available, how does offline work? All right, so that's much more secure with smart card compared to MagStripe. MagStripe, there is absolutely nothing. You have to go by trust. You assume he has money in his account when you take offline with the MagStripe. Stores more data than MagStripe. And another great thing about smart card is when you have a card, it's either driver's license or credit card or debit card or some other cards. With smart card, it can play multiple roles. It can be credit, debit. It can be your healthcare identification card. They could all be in one. You see where the future is going finally? So they all could be there on one single card. Well, if you lose the card, that's a whole different thing. But still, if you lose the card, still there are some built-in securities in there, so that could save you. There's a chip, like I said, right? Smart card. There's a chip. And there are certain applications sitting on the chip. Now, when I say application, just to make it simplified, let's assume there are a set of rules as to how the reader or the payment device should behave, or what should happen if there is no online connection. So let's call the rules as payment application for now. It's a little bit more than that. And it stores information securely. It's not easy to read what's on the chip. Perform cryptographic processing, encryption, and all of that. We'll talk a little bit more on that. That's a huge subject, how the encryption is done. And there are two means of making connection with the payment devices or the readers, like I said. One is contact. You take the card, and then you slide it in. You insert it into the payment device, and then it reads it. Other one is contactless, tapping the card on the reader. There's a difference, and we will also talk about what's the difference between these two when it comes to, it's the same card, but what would happen in the background as far as the processing is concerned. And the thing is, if a card has a chip on it, there's possibility there is also a magnetic stripe on the back of the card. And you take it to a reader that's capable of reading the smart card, and you try to use the mag stripe, it may refuse it. You have the smart card, use it. It may, because some may allow it. Okay, so next slide. Okay, so one or two differences in contact. So contact and contactless. Contact has to be in contact until the transaction is complete. What's the transaction? All the way from, okay, I'm ready to pay for it, slide the card in, yes, and someone reads the data, massages the data, checks and makes sure it's valid, and then builds a package out of it and sends it to the acquirer. And acquirer does a bunch of things, and then approval comes back. And once the approval comes back, that's where magstripe stops. Magstripe is done once you read the card data, whereas smart card, the approval coming back, bank would tell you, I want you to update the chip with this information. So that information goes back on the chip. What are those information? It could be how much money is left in your balance is there, or what's the maximum of offline transaction you can do. That could change, or depending on the country you are in, or depending on how much you are buying, those kind of things. Contactless, it's, well, you don't keep on holding like this until the transaction is complete. You tap, and then you take it out. So when you tap it, it reads the data, and not all the things that happens with contact doesn't happen with contactless. It's faster, but you're paying a price for that. That means you're not, the chip doesn't have all the information that a contact transaction would. Okay, so let's just talk about how this EMV smart card works. In magstripe, after the reading the card, you don't need a card. It's all done. You still have to be around to sign or put the pin in, but it's all done. In EMV, the card data is read, and the rules set by the card issuers are enforced. So it's not just about reading. So what would happen is the payment device asks the chip, okay, what are the applications we want to use, and what are the rules set by the bank? And then they both agree to say, okay, I am capable of enforcing these rules. That's what the payment device says. And if they both match, then the transaction occurs. So all of that handshaking between the chip card, the smart card, and the payment device has to happen while you are paying. That doesn't happen with the magstripe. And the issuing bank dictates which rules are enforced for the current transaction. Once again, a lot of things matter as to how the transaction takes place, what's the offline behavior has to be, what is the identification process that you have to follow. It may be different from country to country. So that's what the issuing bank enforces. And those rules are usually read off of the chip. And for some reason, they're incompatible. Reader says, whatever the rules you're asking me to enforce, I'm not capable. I don't know how to get a signature. Then in that case, no transaction. That's where it ends. That's the refusal. Okay, here is very easy way of putting how EMV works, right? So you start, the reader says, okay, someone is asking me to do a transaction. So now it communicates with the chip, and then chip opens up the communication, the card, and then they select an application. For this transaction that you're doing, this application, these set of rules have to be negotiated between those two. So chip says, these are my rules. Read says, yes, I understand those rules, I can enforce them, right? And then once that happens, the reading of the card occurs. The card data is read. Now, encryption, we come to that a little bit later. And then offline authentication, what's the offline authentication that has to happen? And then it goes to the verify rules. Now that I read the rules, how do I verify that it's set by the issuers allow me to go forward with this transaction? That's verified. And then the verification of the card holder has to happen, right? Do you tell the person to look at the picture of that guy, fingerprints, or PIN, CVM? How do we make sure that's the card holder? So that information is coming off the chip, and then reader is enforcing that. And after that, there is some risk analysis that the reader goes through. What's the risk if this happens? If I have to go offline, what's the risk? And then it tells the chip, okay, this is what I am going to do. And then chip says, okay, I agree. I'm fine with that. My rules allow me with what you're suggesting. So once that happens, now the reader takes the card data and builds a package for the acquirer. And it knows how to talk to the acquirer, and the acquirer gets the package. And that's how the EMV transaction occurs. One thing, it's not complete here, but what happens is once the data comes back from the bank, that may get written to the chip back again. So that's one thing that may be missing here. So as you can see, this is between the card and the payment device or the reader. Now we are going to move up a little bit. We read the data, we read the card. Now what's going to happen? That's only half the story. Reading the card is only half the story. The other half is, now we got to do bank transactions. Someone got to pay for this. So let me just go through. I'm just repeating that. Determine the amount, display the amount. It is a requirement in all countries. You have to display the amount so that the customer says, yes, I agree to pay for that amount. And then you read the card data, request for PIN if required for debit. And then the encryption data occurs, right, once you read it. And then that package, the data you read from the smart card is sent to the acquirer. Who sends it? In this case, mobile devices sends it. Our devices, Motorola devices sends it, not the payment device. Payment device is not capable of communication. Mobile devices are. So it can be through Wi-Fi or it can be through WAN. So the data goes to the, where is this? Acquirer. Acquirer gets the data, does a bunch of things, and then say, oh, this is Visa, this is MasterCard. Let me pass it to the card network. It goes to the card network. They do a bunch of things and then say, who is the issuer of this card? Oh, it's Chase. Let me send it to Chase. So it goes to Chase. Chase is the one that checks, do you have enough money to pay for this? Yes, is it verified? Authentication is done. Yes, everything checks good. And then it says, okay, pay for it. So that's, we already jumped 3. Now, in the future, that number of jumps we have to do may come down in numbers. Why go through acquirers? Why not go to the Visa, MasterCard directly, right? So that's the request going to the bank, to the issuing bank, card issuing bank all the way. And this is the data coming back from the card issuing bank. So card issuing bank says, okay, he has enough money, enough funds, approve it. And that goes to the acquirer. I'm sorry, that goes to the card network. Card network, from there it goes to the acquirer. Acquirer sends it to the merchant. Merchant says, oh, nice. Now signature capture. Now signature capture is a kind of a weird thing. PIN has to happen before the transaction begins with the bank. Whereas signature, depending on the country, either signature is part of the transaction or it's not part of the transaction. If it is not part of the transaction, what's the signature for? Just so that you can verify who the person is. You look at the back of the card and see if the signature matches. How many people do that today? Very few. But it may be different in some other countries. The regulation may require that you pass the signature to the bank, and bank stores the signature with them. So that's where the sale completes. Merchant prints the receipt, and that's the end of the transaction. So, and there are some fees involved in here, obviously. Customer pays. At the end of the month, you get a big, thick bill, right? And you pay the issuing bank, your Chase and Bank of America and all of them. They take a cut out of that. And then card network, American Express and Discover, MasterCard, Visa, they take a cut from the money you paid. And then acquirer or the gateways, they may take a cut depending on the kind of, if you're a mom and pop store, you are working through acquirer, they will get a cut. And then finally, merchant gets paid, right? So by the time merchant gets paid, all of them got their fees. So that's the fees. And we're not even talking about the government taking cut out of this. That's a whole different thing. So what's the EMV adoption? What country is using EMVs as of today, and how much are they using? This is the data that we got from EMVCo, probably more than a year old. So it has changed a lot since then from what I understood. If you look at that, Asia has about 26% of its cards are smart cards, whereas 42% of the terminals or the readers are capable of taking the smart card. So it hasn't kept up. That means merchants are much faster than the issuing bank. Banks are not fast enough in issuing the smart cards. And if you come to Europe, which is much, much higher, and that, from what I was told just a few days ago, that is wrong. That says 65% of the cards issued are smart card, and 85% of terminals are capable of smart card. That's not true. I heard it's almost 85% cards are now smart cards. And terminals are almost 95% of the terminals are capable. And if you go to Europe and then you try to use your magstripe, people look at you nowadays. Canada and Latin America is about 26% of the cards and 55% of the terminal. I didn't get a number for US, so probably it's less than Canada. That's what I'm thinking. Okay, so now that's the basics of the payment, how the payment industry works, what should happen, all of that. Now, what Motorola is offering for the payment solution. The device is called MPM 100. It was released just a few weeks ago, a couple of weeks, 3-4 weeks. So what does it do? It does all the three: magstripe, contact, and contactless smart card transactions. It can also do NFC if you have the right application running on the reader. When I say NFC, near field communication, It includes payment. If you're doing a tap, it is NFC by application. But it could be more than payment. It could be healthcare industry. It could be transportation. You could be using that for different applications. So this is capable of doing NFC, but you may require additional application to run on that. Right now, out of the box, as far as I know, it can only do payment. There is another difference between NFC and payment. Payment maximum is 4 centimeters. You have to be within 4 centimeters for it to read the card, whereas NFC allows a little bit more than that, maybe up to 8 or 9 centimeters, or maybe 10 centimeters. So even though NFC allows it, the payment requires only 4 centimeters. So it has to change what the range is for the payment. The transaction is done through Bluetooth, like I showed before. Where do you use it? The smart cards or the MPM for that matter. There's a huge interest in the MPM. Retail, hospitality, transportation, field service, government, and public. So it's coming our way. And payment industry is changing in a big way, and it's going to change in a very, very big way in the next 2 to 3 years. That's the way everybody is looking at. A bunch of our devices support this MPM 100, ES400, MC55, MC65, MC95, ET1, MC75A. You can use all of those. Pretty much any device with Bluetooth can work with this, but we are limiting the number of devices for now because we don't want to support too many right from the beginning. These are specifications. I'm going to skip this because you can see that what it's capable of and how it's. It has a display, small display that you can say, is it credit or debit? Do you accept it? Those kind of things. We talked about the differences: MagStripe, smart card, chip and pin, and contactless. The only thing I'm going to mention here that I didn't mention is probably MagStripe, easy to counterfeit. It's an old technology. And it's low cost, very, very low cost compared to the other two. Whereas the other two require new infrastructure, and it costs more for all, for the merchant, for the card networks, and the issuing bank. For all, it takes money. Okay, communication with the mobile device happens through Bluetooth, SPP profile. It can work with either Microsoft Stack or Stone Street Stack on Windows Mobile, on Android, BlueZ Stack. Just to let you know, we are not supporting CE devices with MPM as of today, only Windows Mobile devices. Configuring is just, the thing is, you got to manually do the manually pair with the device before you can use MPM. I'm just showing how to do this with both Windows Mobile and Android. I'm sure you all know how to do that. Fraud prevention. This is the biggest question. How easy is it? How hard? So there are a bunch of things that happen. Encryption is one of the big things. Encryption is, once again, dictated by the issuing bank. The issuing bank, sometimes the countries may have certain requirements. Basically, the issuing bank says, I want you to use this encryption, and when you swipe your card or when you insert your card or tap your card, that data gets encrypted using that encryption that the bank said to use. And then the data goes to the bank all the way, and nobody can understand that, and only bank bank knows how to decrypt. So there is one of the security provided. And how does the encryption get on this mobile, on this payment device? Different banks, right? You go to a different country, they may require a different encryption. So there is a process called key injection that you do. Not everybody can do that. So if you just buy this, you can't do key injection. You got to send it to Motorola certified offices. They have a special tool to do key injection, and it requires special keys and everything. And even those keys are only half keys because the other half key goes with the bank. So that is already built into our devices, both in hardware and software. And also, if someone is trying to break in and trying to obtain the seed number for these keys, NPM is built in so that it just wipes out everything and you can't use it anymore. Certification. This is another major step. You can't use these devices without getting certifications done. You just can't. It's illegal. So you go to a different country, they will have different certification requirements. So writing your application is just one thing to do. And then there is this whole process of getting it certified. So that's country certification, right? US has different certification rules. Canada has different. And the Europe itself has different certification rules. Within Europe, Germany and France, they all have different. So you don't think that, oh, I'm getting into payment business. I wrote my application. I'm going to start selling it all over the world. Ramp-up time is there. It costs money. We do certify. When we certify this device, this hardware. You can't tamper with this device. And the software that comes on that. We certify that. But you may have to certify your application that runs on our Motorola mobile devices. You may have to certify that also depending on the country and the banks that you're using. So that is something you got to take care of. We can try to make it easier for you so that the amount of things that you can do, the level that you can go, we can limit that only to a higher level so that your certification is very fast and easy. Okay, what does certification look for? They want to make sure it communicates well with the network, it doesn't interfere with other transactions, it doesn't intercept other transactions. They want to make sure. And in addition to the country certification, there are other certification required, PCI certification and EMV certification. They're all different. So there is something called international certification. You can get that. If you get that, you go to a new country. It's possible they will say, oh, you did it in US, fine, we'll accept it. They may say it. Or they may say, you have to go through additional certification. Or they may say, I don't care what you did. You have to go through certification right from the start. There is no standard certification for the entire world. Like I said, Motorola certifies, but your application still may have required certification. When the device is sent to an independent lab for this certification, they may take anywhere from 1 to 2 months for certifications. That's the length of the certification depends on how well your device, the architecture of the software and hardware is. There is public area, there is private area, how well they're differentiated. So private, if you can say, this is the private and this is the public, and it's easy for them to distinguish between them, then it's faster. Okay, so there is no universal role. Must certify device in country prior to sale. I have heard some people in US using their devices and applications without certification, but that's not the route you want to go. Okay, so that's NPM, Motorola payment device. Now we are getting into the developing the application. Yeah. Okay. We talked about RhoMobile version Suite version 2.0, right? That came out. That has the capability to talk to NPM. So I'm explicitly saying talk to NPM, not do payment here, okay? As beta. It's not completely supported. It's not formally supported. It's going to be supported by Q3, end of Q3 this year. But you can use it. We have tested it, and some of our partners are using it. You should be good. EMDK for .NET, if you're writing .NET applications, It's also maybe depending on what kind of interest this generates, we may do it in Q3. No plans for C or Java, whether it's on Java on Windows Mobile or Java on Android, no plans for that. So right now we're looking at RhoMobile Suite and .NET. I'm going to skip this. You all know RhoMobile very well, right? So the only thing I'm going to say here is the component of RhoMobile, that's RhoElements, is the one that will support NPM only through JavaScript functions for now. And as we move up the chain and add more value to this, it is going to be it's going to support in all other different forms and other things that RhoMobile offers. Right now, it's JavaScripts only. Okay, RhoElement, so application. So with RhoElements, you can also do the other things before and after payment, right? Payment is the word, and then there is the password, right? Point of sale. The point of sale includes all the scanning and printing, signature capture, and all of that. And RhoMobile is capable of scanning, signature capture, printing. So the signature capture has to occur on Motorola mobile device, not on NPM device. The PIN has to occur on NPM device, just to set the rules here. So RhoMobile lets you scan, lets you capture the signature, print, all of those things. Like I said, JavaScript is the only way to access NPM device today. And the help that's distributed with RhoElements 2 does not include any NPM documentation. Like I said, it's beta. So, and also the plan is moving forward. We are not just going to open it for everybody. We want to have some kind of a partnership with whoever wants to do payment application. The reason is payment is not just about writing application, right? We want to be responsible. We want our partners to be responsible. So if you need documentation, you need to contact Motorola TA, and they should be able to get you something within a few hours. And it also requires a PIN before you start using the APIs. This is not the security built into the RhoMobile. This is an additional security before you can use NPM. It's not really a security per se. It is just so that we keep track of people who are our partners and who are using this, so we know who is working with us on this. And there is a programmer's guide in the documentation on the NPM. Take a look at that. It gives you a lot of helpful hints how to write applications. This is the architecture. So this is where your question gets answered. So this is the domain of the NPM. And this is the domain of the mobile device. And above that, it's all acquirers, gateways, and whatever the infrastructure you have. It could be, acquirers, I say here, customer payment gateway. So if you are a big company, Walmart, Targets, they're not going to go through regular independent acquirers. They have their own infrastructure. They do a lot of other things before the payment begins. Well, independent acquirers are for small businesses. They want to set up something fast and easy, so they go to the independent acquirers. So on the mobile side, there is Motorola drivers. Above that, RhoElements framework. And above that, your application sits. And your applications what your application can do with RhoMobile is talk to the NPM and then throw a bunch of menus and commands on the NPM, get the input, whether it's a credit or debit, service charge, do you accept service charge, all those kind of things. And then at the end, the card data itself. It can take all the data, and that's what RhoMobile lets you do. After that, it is your responsibility what you do with the data. That's where this customer customer row application that you will write, and customer created country bank specific code. Any process that requires you to do certain special things, you have to figure that out depending on the country, depending on the bank. That has to happen on the software application side today that you have to do. So now you fulfill all those requirements. You go get the card data from NPM, right? Now what you're going to do with that? You got to pass it to someone else who is going to do the bank transaction. Once again, that's your responsibility today. There are so many acquirers, so many different types of gateways, and now others are also opening, like Visa, Amex are opening up, so you can do direct transaction with them. So all this, we are not helping you with this. You know the best at this time. So we are giving you a means of collecting the card data and passing it to you. And once it goes to the acquirers, once it goes to the issuing bank, gets approved, issuing bank sends response back, you say, oh, I got the response back. Now it's your responsibility to write it back to the smart card, and we give you a bunch of APIs so that you can write back to the smart card. So our role is between Motorola mobile device and NPM. Thus, we facilitate communicating between these two hardware. But that may change in the future. I'll come to the final one. I don't have a lot of information on that, but our vision is to make it much, much easier than where we are today. Okay, I already explained you what you can do using RhoMobile. Okay, go ahead. Jess? Oh, okay, I'm sorry. What you can do with RhoMobile Suite, you can scan items, you can take picture of items maybe for returns or something like that, connect to NPM using Rho elements, display message and prompt menu on NPM, allow customers to swipe, insert, or tap the card on NPM, allow customers to enter PIN on NPM, obtain card data and encryption and clear from NPM. Who would want to do clear? Write to the smart card once the bank response is received, and signature capture on mobile device and print device. RhoMobile allows all of these things. What your application has to do, currently, I emphasize the word currently, Rho Elements does not offer any feature to perform country-specific requirements that you may need to do in your application. You have to have this knowledge. You got to figure out where to get this information from and implement them, get certified. You have to write your own process to create the payment package and pass it to the acquirer gateway. That's your job. You must have detailed knowledge of acquirer requirements and their interfaces. That may include, the encryption and all of that. You must understand all the certification requirements for all countries that you wish to use. You must certify your payment applications if necessary. Well, you will have to. Once the bank response is received, your application must know how to read the bank response and do post-payment writings to the smart card. So whatever the format it's coming back from the bank, you should be able to parse it and then put it into our structures so that it goes on the chip. They're all different tags in the chip. So each tag has a value, so you write to the tags. We provide a number of functions for this purpose. So here are some of the APIs that I'm just going to go through real quick. First, you open the NPM, and the passcode is the one that you have to get it from Motorola. It's not really secret about it. It's just, like I said, that you work with us, you get the passcode from us, and you get support for this. And then COM5 is the port, Bluetooth port that you're using. If you're using Android, it doesn't matter what the port is. And all the function calls you make in JavaScript, they all come back in a callback. None of them are synchronous. They're all asynchronous call. So how do you set up your data? Event callback is shown there. And then when you get the callback, you get two parameters. One is data, success or failure, card data, all of that information. And then the function that it is returning so that you can keep track of. So I did an open, and it comes back open, successful. So you know open was successful, since this is an asynchronous call. Open, we talked about that. And then obviously there is close. Before you do open, you got to manually pair with the device. That's your job. You can write code to do automatic pairing, but this one doesn't do. Close doesn't unpair. You have to do unpairing yourself in your application. Enable keypad and beeps. For some reason, if you use certain calls, certain functions, after using that function, keypad gets disabled. Maybe a security thing, I don't know. So you have to make sure you enable the keypad before calling the functions that require keypad usage. Pin is a good example of keypad. Key beeps, whether it beeps or not, you can control that. Read card data, that's the biggest one. So when you swipe, you get the data back, and all that information is going to be parsed and put into this as it is, as you see here. Now that's, if it's all clear, you don't have any encryption. Encryption, it's going to come in as one big encryption data back to you, and then you should know what to do with that. Prompt PIN, you can say you got to pass the account number before you can prompt the PIN. Because PIN is for debit, and then what it does is takes the account number, takes the PIN, and creates an encrypted string that you need to pass it to the bank. Minimum and maximum PIN length, whether PIN required or not. And believe it or not, there is allow empty PIN. I don't know why that's there. You can show a couple of messages, and then also a processing message you can show, encrypted PIN data written in the data event. Prompt menu, you can show a bunch of menus and say, do you want credit or debit, or you want to pay service tax, or any other things you can show it. Prompt additional info is 3 or 4 different functions combined into one. If you want to use it that way, it's useful. Otherwise, you will have to use the individual calls. Prompt message, it just shows you the message. Cancel previous method, which is very important because you will have to cancel the previous method so that it goes back to the main screen, the welcome screen. Otherwise, the old message is still sitting there. Create Mac, it creates Mac using the Mac working key. Validate Mac, complete online EMV. This does not do online EMV. It's very confusing, the name of the function, but it completes once the online transaction is done. This is what you would use to write back to the smart card once the bank transaction is complete. And you can also, depending on what's available, you can say, I want to read only these tags from the card, or I want to set these tags from the card. This is not reading the entire card, but I'm interested only these certain tags. That may be anything, any value that the bank is providing. It could be offline, turned on or not. So you read that, and then you can write it back. Now, obviously, you can't write everything. There are certain things you can write, certain things you can't write. Authorized card. Authorized card is, it authorizes the transaction amount on the smart card. You send it, and then this is how much I want to charge, and the reader takes that and passes it to Chip. Chip says yes, and then you're all fine. Remove card. This is for inserting contact transactions. Once you're done, you want to say remove your card, because if you don't do it, they won't know when to remove it. There are some help hints here how we should use it. These are pretty minor ones. Take a look at them, and there are more in the programmer's guide that comes with NPM. Take a look at that. So that's what we have today. And what we want to do tomorrow is a whole different thing. So our vision is to create a solution that makes the payment application even simpler. Because of encryption, how about if encryption is via some remote? And those are the ideas that are in our mind. It's there in the industry. It's not like we are inventing anything. And how about all these acquirers and all these banks with different regulations? How about if we take care of all of that, and all you have to do is say, I want to use this acquirer. So that's one of our vision. This is all a vision right now. We're exploring options. And provide interfaces to major acquirer. Like I said, you don't have to spend time and effort to understand. All you have to do is set up a business with them, come back and tell us what you did with them, and we take care of all the transactions behind the scene. Our goal is also to achieve simplification and abstraction of interfaces to different things. Today's MPM, it could be different devices, different hardware vendors in the future, different mobile devices. Maybe we go beyond Motorola devices to other devices. Maybe PCs, we can use this with PCs. Different payment technologies, languages. It got to be, the way I see it is everything got to be language agnostic in the future. It shouldn't be limited to any one particular language. Communication, how the communication occurs, who takes care of the communication, who switches from wireless WAN to Wi-Fi. Why do you have to write code for that? You tell us under what conditions you want WAN, under what conditions you want Wi-Fi. It could be geographic location, it could be time of the day, or it could be some kind of acknowledgement from the user. Acquirers, card networks. We want to simplify this, we want to abstract it. Another vision is to reduce the amount of certification you will have to do with your application. So the more we do all of these things I said and get it pre-certified, the less you do when you write your application, because it's already taken care of. Your application is passing all this information, or it's just listening to this one big black box running on mobile device and MPM device that's already certified. So you can't really mess with that. If that's the case, your certification is a breeze. And all this power and new features, and there are a lot more things I'm not mentioning here, is through, not by coding the way we see it is. Coding has to be minimal. It should be through GUI configuration. You say, I want this feature, I want this feature, I want this feature. Even the scanning, we can do it for you. You don't have to do the scanning. You say, when I scan it, you tell me what data you got, and we'll do the price check for you, or you can do the price check for us. So these are all the things we are looking at very actively. I guess a lot of this depends on what we learn from what we have today, and also your inputs and your comments. Thanks a lot. Thank you.